Okay, Algebra 2, we're going to move right along and go back to Chapter 8. I kind of skipped over this chapter because it was going to be easier to teach in class, but since we're definitely not going back to class, we better cover it. So Chapter 8 is all statistics stuff, and I think several of you are going to kind of like this example, or this chapter, because it has to do with data and like mean and median mode, that type of thing. Okay, so they're going to start talking about statistical studies and how they're basically set up, and you want to make sure that certain things are in place for a statistical study. So they first talk about random sampling, and I want to make sure that my sample is as random as possible to help eliminate any bias. Okay, that's one of the vocabulary words that's in here. Okay, bias is bad. Bias is like showing favoritism. So, you know, like if I am gonna ask what students think of the cafeteria lunch, I'm not gonna strictly just ask the students who leave for lunch, because most of the students are gonna say, yeah, the cafeteria lunch is gross. You know, I'm going to want to make sure I ask a mixture of the people who leave for lunch and the people who stay for lunch to help eliminate as much bias as possible. Okay, so things that we're going to look at in stats examples are parameters, which are mean, range, variance, maybe standard deviation is in there, mode is also in there, you know, things like that. And all of these are called statistics. Okay, in these studies, a sample of the population is taken, which are statistics. Statistics help describe parameters. Okay, so when we take a sample, we have a statistic, which helps us make inferences and describe the population. So statistic and sample go together, and parameters and population go together. Okay. So I'm going to gather information from a sample, formulate some statistics, and then it helps me describe the entire population about the parameters. Now, I don't want to have to survey everybody in an entire population, because that would be a lot of work, right? If I'm surveying everybody in the United States, that would take me forever. So I just select a group of people, and then I use the sample stuff to describe a population. Okay, so the steps that I'm going to take for a statistical study, I want to first identify what I'm trying to get out of this study. Then I'm going to choose my sample, and I'm going to do that as randomly as possible. So I want a random sample. Okay, then I'm going to organize the data. I'm going to find the mean, median, mode, whatever stats that I'm going to need, and then I'm going to use that to talk about my population. Okay, and so all right, so there are a couple different things that I can do to study information or to study data, and that is taking a survey, conducting an experiment, or doing an observational study. Okay, so those are kind of the three types that we're going to talk about. Okay, so a survey is just asking somebody something. Okay, so you're asking a question, asking questions. Now this might be over the phone, this might be through pencil paper, this might be, you know, online, you're asked to survey, that type of thing. Okay, difference between survey and experiment. An experiment, you're actually doing something. Okay, so we do something to a group of people. Okay, and what you're going to do in your experiment is you have an experimental group, and then you're going to have a control group, and you're going to look at both of those. So you guys have probably heard about this in science class, but you'll do a double-blind study if you're doing an experiment to see if like a prescription medication works. You're going to give the medicine to one group of people, you're going to give a placebo to another group of people, and then you're going to study to see who shows improvement and who doesn't. Okay, so I'm actually administering medicine. Okay, so I'm going to do example. Example, giving medicine to a certain group of people. Okay, I'm actually doing something. In an observational study, I'm just watching behavior, watching people's behavior. Okay, now a reason why I might want to do this, to watch people's behavior, okay? Let's say I'm trying to figure out, since the COVID-19 thing is going on, I'm trying to figure out what % of people actually wash their hands correctly and do the whole 20-second thing and are doing what they're supposed to be. So if I go and ask you, okay, are you correctly washing your hands right now? I'm guessing the large majority of you guys are going to be like, oh yes, of course, I wash my hands very good, and I'm doing exactly what I'm supposed to be doing, which is probably a lie. Okay, I know I don't wash my hands as often as I should, but if somebody comes up to me and says, are you washing your hands? I'm probably going to say, yeah, right? I'm going to lie to them, okay? But rather than surveying them, which is going to lead me to a lot of inaccurate data, because they're going to lie to me, what I would do instead is I would observe their behavior, okay? And you would probably have to do this maybe like so that they wouldn't know that you were watching them, probably. But like setting up a camera in a bathroom, not in the stall, okay? So we're not getting any disgusting things, but setting up a camera directed just at the sink, okay? That way I can go through and see who washes their hands, who doesn't, who washes it correctly, and I'm going to get more accurate information by just observing their behavior, okay, with them not knowing that I'm doing that, rather than asking them the question, okay? Another example of this would be like women, especially middle-aged women, okay, if you ask them what their weight is, they're very sensitive to that. They don't like for people to know how much they weigh. So if I go and ask a woman how much she weighs, she's probably going to lie to me and tell me 10 pounds lighter than what she actually is. Versus an observational study would be actually like in a doctor's office, making them stand up on the scale, observing, writing down their weight, and then recording it from there. Okay, I'm not going to just ask them, I'm going to actually observe them standing up on the scale and write that number down. Okay, so there's a time and a place for each one of these, and that's what we're going to do in the next part. So they want us to classify the study types. So in part A, they say, is this a survey, an experiment, or an observational study? And we're going to abbreviate. We'll do SE, SE, and O. Okay, we'll use those as abbreviations. So a band wants to test 3 designs for an album cover. Here are the sample 3 designs, okay? They randomly select 50 members of their fan club to view the covers while they watch and record their reactions, okay? While they watch and record their reactions, okay? So which one is that going to be? A survey, experiment, observational study? They are observing. So this is going to be an observational study. Now, I could have just asked them, okay, do you like any of these? But a lot of times your opinion, or like after the fact, you're gonna change your opinion ever so slightly, but your first reaction might be different than that, okay? So if I look at something and I'm like, oh, that looks terrible, my facial expression is gonna show that. And then I might lie to them and say, that doesn't look too bad, but my first reaction kind of said, oh man, that's really ugly. So that's why they're doing this as an observation, because my first reaction might be different than what I actually try to sugarcoat, I guess, and give feedback to them, okay? Next example, they say the city council wants to start a recycling program. They send out a questionnaire to 200 randomly selected citizens asking what items they would recycle, okay? They're sending out a questionnaire, which means they're sending out a survey. So this is going to be a survey example, okay? Same thing with the next one. Determine whether each situation calls for a survey, experiment, or observational study. Some of these can gonna be a gray area. So some of you might think it's a survey, but it's actually an observation. So there are some cases in here where I'll take multiple answers, but this one says a pharmaceutical company wants to test whether a new medicine is effective, okay? Now we have to decide what we're gonna do in this case. Are we going to do a survey to see if the new medicine is effective? Are we going to do an experiment? Are we going to do an observational study? We could do a survey, but there might be people that say, oh yes, I feel so much better, when they actually don't, right? And some people's definition of feeling so much better is different than some other people's definition of feeling so much better. So in this case, I would conduct an experiment where you give some people the medicine and some people don't. And that's probably the best way to do any pharmaceutical testing, okay? Next one, a news organization wants to randomly call citizens to gauge opinions on presidential elections, okay? In that case, what we're probably going to do is we're going to do a survey. Since we're calling, that's going to be the best way to gauge opinions. Especially if we're calling, we can't really do an observation because I can't really see their face unless I FaceTime them, you know, whatever. I can't really gauge their opinion based upon that, so I'm going to do a survey instead. Okay, now, after we've decided survey, observation, experiment, let's say we come up with this data down here. And it says a random sample of 684 students, that's my total number, at Sanchez High School were surveyed to asked to name the type of technology they would most likely use for learning a foreign language. Okay, so if they're going to use a smartphone, a tablet, a laptop, or a desktop. Okay, so this one is labeled with 20. This one's 25. This one is 15, looks like. This one is 20, so I'm going to label those there. Okay, now they have only sampled a few of these. They haven't asked every single one of the 684. They've only sampled this many people. Okay, this many people would be 20 plus 25 plus 15 plus 20. So this is 45 and 35, which makes 80 people. So they've surveyed 80 people. Okay, not all 684. They've only surveyed 80 people. Based on the results in the bar graph, what is the most reasonable inference about the number of students at Sanchez High School who would like to use a tablet for learning a foreign language? Okay, so what we're going to do in this case is I'm going to say that tablet, okay, there was 24 people or 25 people out of 80 that liked using a tablet, okay? And what I'm going to do is I'm going to set this up as a proportion. 25 out of 80 is how many out of 684, right? Okay, so 25 liked the tablet out of 80 total. That means how many liked the tablet out of 684 total. And what I can do from here is I can just cross multiply and divide. Okay, since we have a proportion, we can do that. I'm going to call my question mark x. Okay, so we have 80 times x. I'm going to write that as 80x. And then I have 25 times 684. Okay, 25 times 684. 25 times 684 is 17100. And then to get the x by itself, I'm going to divide by 80. And divide by 80. So that means about, they say 213.75 or 214 students will prefer a tablet, approximately. Okay, so this is the scenario where we use the sample to make a generalization about the population. Okay, all right, next one, example 4, last one. Jamar surveyed a random sample of his high school film club. He found that 30 out of the 40 members that he surveyed also play video games. So I'm going to write that down. 30 out of 40 play video games. Play video games. Okay. He uses this survey to infer that at his school of 800 students, approximately 600 students at the school play video games. Okay, so he's saying that if he were to have asked everybody at the school, and there's 800 at the school, that 600 probably would say that they like video games. Okay, well, I guess that makes sense, right? 30 over 40 is 3/4 if I knock off a 0. 600 over 800 is also 3/4. So doesn't that make sense? You know, that he would conclude that? Well, it says identify and explain any bias that might affect the validity of Jamar's inference. So he made the correct inference, but look who he surveyed. The high school film club, right? Well, if people are in film club, are they probably more likely to play video games? Yeah. So he needs to survey students who are not in the film club also. So he came to survey some of the students in film club, but not all of the students can be in film club that he surveys, otherwise he's going to get some biased results. Okay, you need some students who are in the drama club or the music club or whatever else. He needs a full representation of everybody, because film club people are more likely to probably play video games. Okay, all right, so this is kind of an introduction into statistics and such. There you go.